Good morning everyone. Welcome back to Kendriya Vidyalaya Khammam online classes. In this session, we are going to discuss chemistry for class 12 students. We are in the discussion of solution chapter. In the previous lectures, we discussed about different concentration terms which includes number of moles, mole fraction, molarity, weight by volume percentage, weight by weight percentage, volume by volume percentage, etc. So, in this lecture, we discuss about solubility. Solubility, what is the meaning of solubility? Solubility of solids in liquids, solubility of gases in liquids. In that solubility of gases in liquids, we are going to discuss about Henry's law and its applications. Then we move on to the solubility of liquids in liquids. Solubility of liquids in liquids. Therefore, let's move on to next slide. What would be there for us to discuss? Solubility. What is the meaning of solubility? So, we are going to dissolve some substances like sugar in water to make gulab jamun recipe. That is my favorite example because everybody is going to face that problem in their life once or twice in a year definitely. Means ready-made sops are came, but we are going to make gulab jamun recipe in our home. Yes or no? So, at that time you are going to need thick syrup of sugar, but it cannot be directly got from dissolving sugar in water. You are going to do heating and etc. So, this concept is going to clear the doubts why you are heating to make a thick syrup of sugar from the sugar and water. Let us see what is solubility. The maximum amount of substance that can be dissolved. See, the maximum amount of substance that can be dissolved in a specified amount of solvent means solvent is a fixed quantity at a given temperature. Temperature is a fixed quantity at a given temperature. So, let us take, you are taking glass of water. So, you are having bunch of sugar. How much amount of sugar is able to dissolve at that temperature is known as solubility of that substance. Okay, solubility of that substance. So, solubility is equal to the, we are having the formula, solubility is equal to weight of the solute by weight of the solvent into 100 grams. Okay, we are estimating solubility per 100 grams. So, the maximum amount of substance that can be dissolved in a specified amount of solvent at a given temperature is called as solubility. Okay, so solubility has the formula weight of the solute by weight of solvent into 100. Let us see what are the factors on which solubility depends on. Means on what factors the solubility or dissolving. Solubility is nothing but dissolving of any substance into the other substance. On what factors this solubility is going to depend or dissolving capacity is going to depend. So, solubility of a substance depends upon nature of solvent. Solubility of a substance depends on nature of solvent and solute. Nature of solvent and solute. It is like you cannot dissolve oils in water. You cannot dissolve oils in water. Yes or no? You daily observe that. You can dissolve alcohol in water or oil in oil, but you cannot dissolve oil in water and etc. Yes or no? So, the solubility of a substance depends on nature of solute and solvent, both in which you are dissolving, which substance you are dissolving. Second thing is temperature. I told you if you want to make a gulab jamun recipe and you want to have a thick syrup of sugar, definitely the mixture of sugar and water should be heated on the stove to get thick syrup. Otherwise, by simply dissolving sugar in water, you would not get that sugar syrup. Then pressure. Pressure is also going to play a key role in solubility of a substance. So, three factors are main factors are nature of solute and solvent, temperature and pressure are the three factors which are influencing the solubility of a substance in other substance. So, in solubility, first of all, we are going to discuss solubility of solids in liquid. Solubility of solids in liquids. Dissolving of solid. So, one substance, whichever substance you are dissolving, that is called as solute. That is called as solute. The substance in which you are dissolving is liquid. So, already in the introduction part, we discussed that we are going to discuss only liquid solutions. Liquid solutions means the solvent is always a liquid. Therefore, while dissolving a solute in a liquid, to form the solution is called dissolution. Okay, dissolving of solid in a liquid is called dissolution. So here solute is solid and solvent is liquid. So what is the opposite of dissolution? The opposite of dissolution means the process in which solid is separating from the solution is called crystallization. Means if you take a saturated sugar syrup, whatever the sugar syrup you made by keeping on the stove, if you keep for long time without disturbing, you can find the crystals of very fine crystals of sugar underneath the vessel. So the process which is opposite to dissolution means the dissolving of solid into solvent to make a solution is called as dissolution process, and the opposite process is separation of solution into solid and solvent is called crystallization. See, what are the factors affecting of a solubility of solids in liquids? Three factors we discuss: nature of solute and solvent. Let us see what would be the effect of nature of solute and solvent. Always remember the point, like dissolves like. Have you tried dissolving sugar in oil any time? If you do not try, please try now. It's not a dangerous experiment. If you take a small pinch of sugar and try to dissolve that small pinch of sugar in oil, vegetable oil or kerosene or petrol, okay, observe that whether it is dissolving or not. Dissolving or not. Definitely the solid, whichever sugar you are taking, that is not going to soluble in oil, because the statement it is telling like dissolves like. Polar solutes dissolve in polar solvents. Non-polar solutes dissolve in non-polar solvents. What is polar? Polar is nothing but polar means charged. Okay, whichever molecules having charge, they are going to dissolve in charged solvents. Water is having a charge separation. Charge separation, that is a dipole. So that sugar is going to dissolve in water, but oil is a non-charge. It doesn't contain any charge separation in oil, but sugar is going to have some charge separation. That's why that is sugar is a polar compound while oil is a non-polar compound. That's why sugar is insoluble in oil. Okay, so always remember this statement, like dissolves like. Like dissolve like. Similar natures compound mix themselves, while dissimilar nature compounds would not mix themselves. They are going to separate like oil in water. So example, if you take in your home you are having sodium chloride, that sodium chloride dissolves in water. Water is a polar solvent. Sodium chloride is an ionic compound. Definitely it is having charges. Therefore, sodium chloride is going to be soluble in water, but not in kerosene. You can do also this experiment. If you mix salt in a kerosene, you can observe that salt is not going to soluble in kerosene. And during solubility of solid in liquid, dissolution and crystallization won't exist in equilibrium. During solubility of solid in liquid, dissolution and crystallization both exist in equilibrium. Okay, don't think that only solid is going into solution. Okay, from this solution, solid is also going to come outside. Let's see what it is telling. So, when solute plus a solute is dissolving into solvent to give solution. What is this process called? Mixing of solute and solvent to form a liquid solution is called dissolution. Then, what is the opposite process? The opposite process is solution, and that is solution is separating into solvent and solute. Solution is separating into solvent and solute. This opposite process is called as crystallization. This both dissolution and crystallization are going to present in equilibrium when solid is dissolving into liquid. Now, when any solid is dissolving into liquid to make the solution, it is going to associate with some sort of heat. So, better example I will give you. While you are making glucose water, by dissolving glucose in water, if you touch the surface of a glucose glass, that solution glass, how the feel you touch, whether it is going to be cool touch or whether it is going to be hot touch. So definitely, while I am drinking glucose, I am making glucose solution. Even before this topics discussion, if before knowing that, I observed that whenever glucose is dissolved in water, the surface is becoming cool. I am unable to understand this concept before knowing these lessons and etc. Okay, so they are going to associate with some absorption of heat or release of heat. Suppose when the laboratory, while you are making sodium hydroxide solution, you have to dissolve sodium hydroxide pellets. Sodium hydroxide pellets, they are very lovely granules, they are going to present. When you are dissolving that sodium hydroxide granules or copper sulfate or potassium hydroxide granules in water, thus if you touch the surface of that beaker is going to be very hot. The surface of the beaker you are going to feel is very hot. So the reason being is they are going to liberate heat because of hydration. Some of the substances are going to absorb heat to dissolve. So glucose is going to absorb heat from the surroundings to make soluble solution. That's why the surface is going to be cool. While when you are dissolving sodium hydroxide in water, because of solvation or hydration, it is going to liberate heat. So some heat associated with dissolution of solids in liquids, that heat we are going to call as enthalpy of solution. Delta H solution is nothing but enthalpy of solution. The heat associated with dissolution of solid in liquid to make the solution is called enthalpy of solution. This enthalpy of solution involves two terms, delta H lattice while delta H hydration. What is the delta H lattice energy? So when you are dissolving sodium chloride solid into water, sodium chloride should break down into Na plus and Cl minus. So the amount of energy required to separate the ionic compound into its respective ions is called as lattice energy. So first of all, so since you are decomposing or you are separating the ions, you have to spend the energy. So delta H lattice is always positive. Okay. So after that, water molecules are going to surround each Na plus. Water molecules, these water molecules are going to surround these Na plus ions. Water molecules also going to surround these OH minus ions. So this is called hydration or solvation. That is, I told you here hydration or solvation is the meaning same. Okay, so delta H hydration is a negative quantity. This is negative quantity, and a delta H lattice is a positive quantity. Both negative and positive make the sum to give delta H solution. It may be positive, it may be negative. Okay, so let's move on to the next slide and check what would be there. So depending on the solubility of solid in a liquid, the solutions are categorized into three types. So now the topic is solubility and the types of solutions. Types of solutions. So if you look onto it, solubility and types of solutions, depending on the amount of solute it dissolved in water to make the solution, the solutions are three categories: unsaturated solutions, saturated solutions, supersaturated solutions. Unsaturated solutions means it can dissolve more amount of solute. Means if you take glass of water, if you able to dissolve, if you dissolve small pinch of sugar in that glass of sugar, if you further adding sugar into that solution, till it is dissolving, that solution is called as unsaturated solution. More amount of solute can be dissolved into a given solution. Then the saturated solution means if you keep on dissolving, solute into solvent, further no more amount of solute can be dissolved. How can it detect? You can detect that no more amount of solute can be dissolved is solute granules remains undissolved and they are going to separate from the solution. So saturated solutions are those in which no more solute can be dissolved. Then supersaturated solutions. So in order to make a sugar syrup, thick syrup for gulab jamun, what you are going to do is you are going to take that sugar solution and heat it on the stove. That solution you are treated as supersaturated solution. Cool it to room temperature. Whatever that solution is called as supersaturated solution. All these definitions are valid at a constant temperature. So, but supersaturated solutions are unstable and they are going to separate into solid and solvent. Okay. So crystallization is going to take place either in saturated solution or in supersaturated solutions. Okay. So then saturated solutions, the solutions in which no more solute can be dissolved, that is the definition given and the underneath. Then in saturated solutions, dissolution and crystallization both are going to exist in equilibrium. Dissolution and crystallization both are going to exist in equilibrium. Saturated solution contains maximum amount of solute dissolved at a given temperature in a given solid. So supersaturated solution contain definitely more amount of solute, but in order to make supersaturated solution you have to increase the temperature. But saturated solution means at that temperature the maximum amount you are going to dissolve to make the solution. So that is the basic difference. Then saturated solutions contains maximum amount of solute dissolved in that given solution. Then supersaturated solutions, if you look at the picture that is given, see if you clearly observe that one, solid supersaturated solutions contains more amount of dissolved solute than in a saturated solution in a given solvent at a specified temperature. Means we are going to increase the heat and it is brought down to the temperature you want, then that solution is going to contain a supersaturated solution. So in supersaturated solution, crystallization is going to appear very fast. see that crystals are forming. You can see that picture. If we keep that supersaturated solution, the crystals are very much separating very quick, very quick. Okay, so this is about solubility and the types of solution. Then first factor we thought is solubility of solids in liquids and the factors affecting solubility of solids in liquids. So in that factors affecting solubility of solids in liquids, we discussed nature of solute and solid. What would be the effect of temperature? So earlier as I discussed, what we discussed, we told that, or we discussed that some heat is going to be associated with the dissolution of solids in solvents to make the solution. That is delta H solution. The effect of temperature on solubility of solids in liquids depends on delta H solution. This is not negative. This is arrow mark. It is printed like that. For dissolution of solids in a liquid, change in entropy is positive because a solid is becoming a separate molecule structure. Solid is becoming into a separate molecule structures, individual molecules. Solid is becoming into individual molecules. Though then, if the number of molecules increasing, if the number of entities increasing, what would you call? If the number of entities increasing, then the entropy of that system is going to increase. Entropy of that system is going to increase. So always dissolution of solid into solvent is entropically favorable. Entropically, we learned that in thermodynamics concept. What is entropy? So delta H solution is positive for solubility of solids in liquids. Then what about delta H solution? If delta H solution greater than 0, means if the process is endothermic, like a dissolution of ammonium chloride in water, or dissolution of the sugar in water, when dissolution process is endothermic, solubility increases with increase in temperature and favors high temperature. Okay, if delta H solution is positive greater than 0, the process is called endothermic. Those endothermic processes require more amount of heat to solubilize the solid in liquid. So solubility increases with the increase in temperature for the endothermic processes when delta H solution is positive. So the reverse is true for exothermic solutions. If delta H solution is less than 0, if delta H solution is less than 0, means a negative quantity, dissolution is an exothermic process. Dissolution is an exothermic process. If delta H solution less than 0, so dissolution is an exothermic process. Means solubility, exothermic process means the substance when dissolved in water, like sodium hydroxide drop into water, or sodium drop into water, or potassium hydroxide drop into water, the sodium is going to react. That is not called solubility. That is called, we are going to call it as reaction. But sodium hydroxide, potassium hydroxide, copper sulfate, when you add into water, the beaker is going to become heat, means they are releasing heat. So it is an exothermic process. So when the process is exothermic, when dissolution process is exothermic, they need low temperature. You should not keep it on the stove to dissolve more amount of solute. So themselves they are going to solubilize more. So solubility decreases with increase in temperature. So they need low temperatures as compared to the endothermic process. Then the third factor, which is we have to dissolve is pressure. As solids and liquids are incompressible, pressure do not have any effect on solubility of solids in liquid. say, don't argue when solids are compressible. If you argue yourself, I can compress a solid into very small piece. See, this water bottle, if we can compress, why to carry this liter bottle? We can carry compress a liter water bottle in a pocket, expand here and drink. But he can't, because solids are less, means you can compress, but the extent of compression you are seeing in solids is very small. It is almost, sometimes it is not negligible, but you cannot find it generally. Okay, so this is the story of solubility of solids in liquids. So let's see next, solubility of gases in liquids. This concept we are going to discuss in the next lecture, solubility of gases in. Okay, so by this lecture we are ending up this discussion of solubility of solids in liquids. Still we are having solubility of gases in liquids and solubility of liquids in liquids. Thank you. Follow NCERT textbook at each and every aspect and do the follow up, do the problems or read the NCERT textbook as much as we can. Thank you.